This week has been a big week for model announcements. We have the Gemini Flash models, we have the Grok 4.6 models announcements. And on the open weight side, we have the Qwen 3.8, which includes this 27 billion model and also the 2.5 trillion model. There's also GLM 5.3, and whilst the open weights has not been released yet, it will be released probably in the next week. And we also have the DeepSeek V4 Pro model, which is a new entrance to the Pareto frontier on the artificial analysis benchmark. This is a very interesting kind of development, because it just shows that the open weights models not only are making and releasing more and more models, they are also challenging the frontier which the labs have generally held. Firstly, what's my first impressions of the Qwen 3.8 27 billion model? Now, these are just initial impressions. The first thing is the MTB model drafting side works out of the box. The model is identical to the old model, the 3.6 model, and it means that it comes with all the enhancements that that model had. So compared with the Muse 30 billion, I achieved consistently 20% faster or better token throughput. The thing that I noticed with this model is the default setting is thinking is at X high, which means it thinks a lot. Looking at Reddit and Twitter, this kind of thinking is actually justified, and people have seen that it has helped with their workflows. But personally for me, I haven't seen any discernible improvements, and right now it's a bit too slow for me to use on a regular basis. So I probably will stick with the mixture of experts. But there's an opportunity here, maybe run it overnight on some hard problems, and maybe it'll come back with the answer. It's something that maybe I'll try later. But back to the open weights announcements and thinking about what this means in the future. So one of the things that has also occurred in this week is that there have been some announcements relating to model routing. And well, I shouldn't say is this week, it's been something that has happened for probably the last few weeks and last month. This week in particular, there was an announcement of the NVIDIA switchyard model, and that switchyard routing approach for the models. And as I pointed out, as the open weights model get closer and closer to the frontier, it just isn't cost effective anymore for people to only use the frontier models. And organizations are seeing this. There was like the whole thing with token maxing, and then people realizing, hang on a minute, there's probably a better way of doing this. So people would use the cheaper models in lieu of the frontier models. And of course, large corporations like Datadog and Databricks and NVIDIA have picked up on this, and they have offered or starting to offer solutions to help improve the developer experience of switching models. And this is a whole routing aspect of things. The whole idea is, if there are cheaper models that are close to the frontier, maybe if we understand the task that you're running ahead of time, we can then route it to a cheaper model and get the same kind of outcome. Or perhaps if someone in the organization is spending way too much on frontier models, perhaps there is a way to not affect their developer experience and still let them continue using the LLMs to get the throughput that they desire. So we're going to talk about some of the ways that these organizations have proposed to solve this problem. So the first one that we're going to touch on is the meta harness. So the meta harness is through the Databricks Omnigent, and the whole idea is that rather than having users just use a harness, maybe there's a harness that chooses which harness to use, and based on that harness, it may then have downstream effects on the model. I think this is a very interesting approach, because rather than silently routing users' requests through the model and then changing how the agent responds, it instead does it much more directly. It's saying, hey, if you use this meta harness, this harness will then choose which harness to use to route the request through. And the idea that they had is that the various harness, so for example, Codex or Claude Code, or maybe like, let's say it was integrated with DeepSeek harness, well, these harnesses are tuned to the particular models. So you can't, or it's not really appropriate just to say, hey, I'm going to use the DeepSeek model in the Claude Code harness, even though you can, but instead, we are going to have this meta harness that redirects the particular request that you have to the particular harness, and that is a way how we will improve the developer experience to support the particular workflow that you're building. So this is a much more direct way of doing this, and they have shown that on their blog site and so on, that this approach has noticeably improve their token spend and also improve their developer productivity by using this Databricks Omnigent approach. And Databricks Omnigent is a Databricks open source piece of software, and it does mostly work in terms of like when I used it, and there are other additional enterprise benefits of having Databricks Omnigent beyond just routing, such as things like sharing sessions and so on, if you use a Databricks product. But not everyone uses Databricks as a product, but it's interesting to see the vendor approach this problem in this kind of way, and also tackle the issue with the developer experience side of things. The other approach is using the control plane, and this is probably the much more obvious approach that someone would have thought of. And this is done by Datadog. Datadog is an observability platform, whereas Databricks is typically known for the data engineering side with Spark and so on. So this kind of approach is, well, if we can monitor users using the token spend and we see that they are overrunning or hitting particular budgets on their token spend, well, maybe we can then rather than having hard token limits, we can then just downshift them to cheaper models so that the developer doesn't have to consciously go and change what they're doing in terms of their day-to-day. So that's how they're tackling the developer experience and also like enterprise compliance and governance. So this kind of approach means that developers aren't dealing with, my API key, I need to change it so that I can go and use a different model, or as a developer, I don't need to be worried about my token spend around what I'm doing, but instead I'm just going to keep doing what I'm doing, and then there will be this kind of control plane to then downshift if I'm hitting issues with my particular setup. So this is a nice way and a different way to how Omnigent is solving it, and it's more geared towards the enterprise governance side of things, as opposed to the Omnigent way, which is trying to tackle the developer experience more directly. So this one is perhaps indirect. The third approach is about NVIDIA switchyard, and this approach is something that the developer initiates. So whereas in the layer 2 with Datadog, it's like the control plane which the developer does not control, right? So the control plane is like invisible to the developer to a degree, and it will downshift the requests. The NVIDIA switchyard approach is much more direct. It is something the developer actually installs over or in conjunction with their coding harness. So it's something like you might install with their Codex or their Claude Code. And what it will do is it will directly route the models in the session that the developer is using to perhaps a more cost-effective model. And when they do that, it will then the goal is to keep the same quality of what the developer is doing, and at the same time reduce the cost. So that's another approach that is controlled by the developer directly, and is a little bit different to the Omnigent or the Databricks kind of way. So through their example that they've shown, they claim that they can reduce the cost by 30% whilst matching the quality by using this kind of smart routing that the developer can control. Probably the last approach is if you just use specialist models entirely, and use it on the edge. And I think this is like related to, say, for example, using Qwen 3.8 on your own laptop rather than reaching out to call an API. And this is a kind of thing that like NVIDIA has invested in. There's the Google Gemini models which run on the edge as well. So for example, the E2B and E4B, which are supposed to run on devices and support like audio and image. The whole idea behind that is if we have these specialist models that run on the edge, perhaps they can run and deal with the request on the device. And if they can't, or it's not appropriate, then reach out via API, and that would drastically decrease the spend that is happening through APIs and token spends, because it's just doing whatever work it can on the device itself. So I think like this kind of approach is probably rarer in large organizations, who most of them would just prefer to pay for a service, but it does provide another option perhaps for people running home labs to control for costs, because if you can just run a specialist model on, say, your DGX Spark, then you don't have to pay money for the expensive models. And this approach probably should be used in conjunction with, for example, the switchyard model. So where you would have you'll have NVIDIA switchyard say, oh, it will use the model that is on device where it can or where it's appropriate, and for more difficult tasks, it will then intelligently route it to, say, the codex or Claude Code with the frontier models. So that's the fourth approach that we can have, and it's sort of like the approach that is teamed up with the switchyard approach. So that's what's going on this week, and where I see the trends are happening. So we have increasingly more and more open weights models being released, which are pushing the frontier labs challenging the frontier labs and probably pushing the boundary for how people think about costs. And we have more and more of these like large enterprise SaaS platforms provide solutions to control for token costs. So we have our Datadog, which provide an invisible control plane more for the governance side, where it would downshift users, and we have Databricks, which are providing a meta harness to improve developer experience by explicitly having this meta harness control and use downstream harnesses to control for the particular thing that they're using for. And finally, of course, we have NVIDIA with their switchyard and edge models, which they want to use to control, which developers can use to control the particular task at hand, so that it will run on a cheaper model or on the edge where it can, and it will route to a more expensive model if it determines that it needs to. So that's what's happening this week and where I see the trends. Let me know what you think.